Now, typically, in 99.99% of the cases, we choose P1 to be at the top of the lake. So what's the value of the pressure there at the top of the lake? Is it 0? It's 1. 1 what? Turns out it's 1, we call it an atmosphere. It turns out that when you're at the top of the lake, you are at the bottom of an ocean. A fluid is either a liquid or a gas. And when you're at the top of the lake, you are at the bottom of 30 kilometers of air. A vast ocean of air. Now in Bozeman, not really 30 kilometers because we're up so high, but still, it's a considerable amount. And so the pressure at the top of the lake is not 0, not even close. It turns out that it's 101,325 newtons for every meter squared. Now again, a newton is only 1/5 of a pound. It's not a very big force. And a meter squared is a big area. So this unit, although the official MKS unit, is pretty small. We call that combination Newton per meter square a Pascal, to honor a dead professor. Good thing to do. And typically, we work in kilopascals because a Pascal is so small. So we say that 1 atmosphere is about 101 kilopascal. And that's what they say in virtually every civilized nation on the earth, except one. America, land of the free. We don't have to conform. What is 1 atmosphere in America? Anyone? 7. No, 7. That was really, really close. You were half right. Okay, it's not 7. It's 14.7 pounds per square inch. Pounds per square inch. What that means is that on every square inch of this milk carton, this great big sea of air is pushing with 14.7 pounds. Well, there's a lot of square inches on this thing. You'd expect it to just crumple right up. And it doesn't, because there's air on the inside as well pushing out in order to balance the push in. Now, if I were to take the air out of the inside with this pump, you can see that it doesn't take very long for that to just crumple up. Okay? Now, that's a plastic can. I assure you it works just as well with a metal can, but metal cans these days are used for paint thinner and things like that, and it's kind of hard to get those metal cans. Now, I was hoping to crush a 55-gallon drum. However, I had the 55-gallon drum. And then the junior high in Livingston called and asked if I would do a demo show for them. This was 3 weeks ago. And so I took my 55-gallon drum and I crushed it. That's the drum. Now, here's how I did it. I put a gallon of water in the bottom of that drum, and I put the drum on 2 hot plates for about an hour. And after about an hour, after about 40 minutes actually, there was steam coming out of the top. A lot of steam. Now steam is water vapor. It's water in the gaseous It's gas water. So when that steam is coming out, it means the air has already been pushed out by the steam. The steam is now leaving, but the air left long before, being pushed out by the steam. So once we get that steam coming out, we take the 55-gallon drum off the heat and quickly cap it off. Now you want to do it in that order. If you do it in the opposite order, it's a bomb. Okay? But you cap that off. And now you've got a 55-gallon drum filled with water vapor. And if you cool that drum down by throwing ice on it, the water vapor will turn back into about, well, half a gallon of water. But that leaves the rest of the space in there as a vacuum, with nothing pushing out on the can. Now, I was standing next to this thing, and it wasn't doing anything. It was just sitting there. And I thought, oh no, hundreds of people in this gymnasium, they're all watching. And I'm thinking, oh man, there's a leak. It's not working. Oh man. I was just about to apologize to everyone. I was just opening my mouth to apologize. And this thing just went, whoo! It just sucked in all at once. Just instantly it went to that. And they loved it. Those junior high kids, they loved that. They loved that. Now, years ago, we did that. To those who expected this can to crush and were disappointed because it did not, I'm trying to redeem myself. We're going to crush this can now. We've been boiling water for about 20 minutes. That boiling water is pushing all the air out of this can. And Trevor, would you come up and help me to take this off the heat and put it on some ice? Okay, put these on, please. And what we're going to do first is put some ice down on the floor. We'll clean it up later. Put a little ice right here. People don't slip on that after class. Now, it's important that we do this in the right order. I'm going to turn off the heat, and I'm going to cap this off. Would you hand me that wrench, please? Okay. Now, we're going to move this down onto the ice. Thank you. We're going to perhaps have some more ice. Cool it down on the fire. Science works. Okay. Yeah, that's what I'm talking about. That's what I'm talking about. Okay. See you on Wednesday.